Okay, thank you for joining us today. Avik and I are excited to share with you the ongoing progress to the Payment Hub Enterprise Edition that's been made throughout the course of the past year. We're looking forward to today's demo and showcase and speaking to the next steps to help build out the upstream community around the Payment Hub and help to further extend it to support the variety of use cases we know it's capable of supporting. And just as we've done around Fynarfin and Mifos and core banking, doing the same around payments orchestration. So I'm going to start with just a brief overview from my side, talking about the origins of the Payment Hub, a variety of the use cases it supports, and how it sits in parallel to Mifos and Fynarfin. Then I'm going to pass it over to Avik from Fynarfin, who is going to speak at a more detailed level to the Payment Hub, what's been improved and implemented over the course of the past year. And then the second half of today's webinar and showcase will focus on the demonstration of what's been improved and worked upon. And then we're going to reserve time at the end for questions and answers. So please, if you have any questions throughout the demo and webinar, please either type them into the chat or the question and answer tool, or feel free to raise your hand at the end so we can take you off mute and answer your question. And then if there are any questions that come up throughout that are relevant and pertinent in the course of what we're presenting, we'll cover them then. But thank you to all who could join us today. And for those listening in, we're looking forward to showcasing the ongoing work of the Payment Hub. So just a bit on the origin of the Payment Hub. I think most are quite familiar with this, but the Payment Hub does represent a good journey of a development of a digital public good, with support from the philanthropic sector, and then the mature growth of an upstream community around it. So we built out the Payment Hub, the initial prototype and proof of concept with support from Dial back in 2019 as a means of demonstrating the power of bringing together two complementary open source systems, Mifos and Fynarfin for core banking and account management, and integrating with Mojaloop as a real-time payment switch. And then in 2020, with a grant from the Gates Foundation and working with DPC around the design and development of taking the prototype to a production-ready architecture, we really built out the Payment Hub to be fully enterprise grade and scalable and extensible and ready for production around high volume use cases, with still the initial focus around connecting into an instant inclusive payment system like Mojaloop. And then over the course of the past year, Fynarfin has been working on a number of projects with customers and contributing back upstream and making a number of valuable enhancements that we'll see today around ease of deployability of the Payment Hub, improved scalability and performance, support for additional use cases, and just making the Payment Hub a more broad payment orchestration engine. So extending upon that initial use case to connect into a real-time payment system like Mojaloop, but extending it further for a variety of use cases that we'll speak to today. And Avik's going to touch on this a bit more, but really the Payment Hub acts as that bridge which connects an underlying payment rail with Mifos or Fynarfin as that digital public good that provides the store of value or core banking or account management. And so let me go on to my next slide. So this just is at a high level, I wanted to show how Mifos and the Payment Hub sit alongside each other. And then Avik's going to speak to this at greater detail. But the Payment Hub here, or the orchestrator, acts as the orchestration engine to really facilitate the smooth and seamless movement of value across whatever channel, core banking system, or platform you are participating in. And so Fynarfin and Mifos serves as a store of value, managing accounts, managing wallets, managing loans, savings, etc. And then the Payment Hub sits alongside it to effectively orchestrate these flows of value across the various accounts that might be connected. And so one key aspect of the design of the Payment Hub has been around this agility and the flexibility and extensibility it can provide. And so we've built Payment Hub around ZB as the centralized orchestration engine to provide a cloud native low code way to orchestrate these various transaction flows. using a simple set of extensible connectors to connect additional core banking or account management systems to connect in the various channels your customers and staff will be interacting with, as well as to connect in a variety of different payment systems and schemas. So really this agility was built in mind to provide that agility on top of the Mifos and Fynarfin core banking system to enable seamlessly connecting into whatever payment system it might be. This could be an instant inclusive payment system like Mojaloop. This could be like the ISO 222 standard. It could be a mobile money API. It could be a shared or distributed ledger system. And then leveraging the channel connectors to enable transactions to be initiated from staff or customers from other device or channel that they're using. And then, of course, by default, we're building out this to integrate with Mifos and Fynarfin, but you could build out whatever connection to whatever account management system or banking system or beneficiary management system the accounts and customers are held within. And so in terms of the payment hub and the benefits it provides, first off, it provides that integration layer, as I noted on the previous slide, with these various connectors that can easily be built. And then it can leverage the low code configurability of ZB by simply configuring new executable Bpmn diagrams to design complex flows across various systems and channels. And this orchestration is not just for payments and the flow of value, but the payment hub can be further extended as a general process orchestration tool to enable additional use cases which others in the community like Fintech Yando have already been doing. And then for those that are using the payment hub to participate in a real-time payment system, it also provides an effective operational control center to monitor both from a business as technical perspective, your participation in the real-time switch or the flow of value across a mobile money API. So really just having the visibility and insight into the digital transactions that are being routed through the payment hub. And then lastly, more of these in-depth analytics, as I noted earlier, at a technical and business level to have that visibility into why transactions might be failing, taking action upon those transactions, and adding in that visibility that you're not getting within Mifos and Fynarfin around this flow of money. And I think I'll just skip over these couple slides here. This is just a slide that we've used previously before speaking to the benefits that the payment hub can provide alongside a Mojaloop system, as well as the ISO 222 standard around enabling cross-border remittances and achieving that last mile delivery and being able to incorporate richer data to have valuable use cases around international remittances. But that was one of the first use cases we were aiming to support with the payment hub. This centers around the Mojaloop integration story, and I'll just skip over that so we have more time to speak to the use cases we wanted to focus on today. And then in terms of how or where the payment hub is being deployed, this slide is continuing to grow. It doesn't reflect some of the use cases that some of our partners are looking to explore. But as noted earlier, the first use case was to really enable participation in a Mojaloop type system. Avic's going to speak to some of the efforts in extending the payment hub to support social protection programs and bulk cash transfers by adding in some of the bulk pre-processing components that is necessary for these widespread payments and dispersals. And then he'll also speak to some of the integration use cases around mobile money APIs, as that's been done for fairly high volume in East Africa. And then Avik has also worked previously on leveraging the payment hub to help build out a closed loop wallet system. And then we do have at POC level integration with the SEPA fast payment standards built on ISO 222. We're aiming to leverage the payment hub to help provide integration to some of the US payment rails through some of the Move libraries developed by that open source community. And then Fintech Yando is also exploring the usage of the payment hub to enable a much more vibrant ecosystem around merchant payments generated through QR codes, et cetera. And then we do have a number of partners in the community who are starting to explore how the payment hub could be utilized to connect into central bank digital currencies, connecting into shared and distributed ledgers. So we're eager to see those use cases get brought forward. And then across Africa as well, we are in conversation with a number of entities who would like to use the payment hub to enable more of that seamless integration with multiple payment channels, but also to help with some of the cross-border clearing and settlement within internal banking networks. And so this next slide here, I'll just skip over this as Avik's going to speak to a lot of it on his slides, but just at a high level, you know, we have built out the payment hub to enable that agility, enabling that ease of integration. We've built it out to support various deployment models, which I think many are aware of. And then we've also built it out with that extensibility in mind. And then lastly, you know, one of our next steps after this webinar is to open up our public lab environment. Again, as we recognize there's a lot of interest in being able to test out and have a sandbox environment for the payment hub. And so we're looking forward to having that accessible again. And so I'm going to stop my screen sharing now and pass it over to Avik for his portion of today's webinar and demo. And as a reminder, please, if you have any questions, feel free to type them in the chat or question and answer section. So Avik, I'll pass it on to you to speak more at the technical depth of the benefits of Payment Hub, what's been worked on the past year, and guiding us into the demonstration.
Yeah, thank you, Ed. Am I audible? No?
Yes, we can hear you fine, Avik.
Right. So I would like to stress on a couple of points which Ed highlighted, right? So a lot of the banking as a service providers which exist and a lot of the core banking systems which exist did not evolve over the last couple of years, but evolved over the last couple of decades. And that is where it's the lock-in and the bundling of services at the banking as a service provider is cumbersome. So what this really helps with is freeing up any kind of now some of those banking as a service providers are modernized with some agility layers on top of it, like GraphQL and API gateways, right? But primarily payments have in the past been bundled together and with UI, with the store of value, with has been always been bundled together with the payment connectors, right? So this provides a way to unbundle it and be agile on the payments piece, right? So you have your accounts, which could be Finaract CN, or any banking as a service provider, right? A reason often for going with the local banking as a service provider is compliance and KYC, AML, all those modules being linked with local compliance rules, right? So it can easily, the payment hub that provides the rails and the rules, and it can easily go and sit on top of an existing banking as a service provider without the need to migrate anything, right? And there's a set of apps which can, again, open source apps, which can orchestrate via the payment hub. For example, the self-service app or the web app which connects with the store of value can also be can also connect to payment hub and have a abstraction layer, which I will go into more into detail later when talking about international remittance. So, right, the ZBA cluster has is primarily used for all the orchestration use cases. It's pushed by Camunda, which has pedigree in writing orchestration services over the last couple of decades. And this time, the ZBA architecture has embedded rocks DB, which can be horizontally scaled. And since it's in memory, latency is less for the different activities which is done during a payment workflow. So low latency is one core consideration when this was designed, along with horizontal scalability. Right. Then for reliability, we have Kafka. So for every event that happens during orchestration, it gets pushed to Kafka, which is as reliable as it comes. And the data layer is completely separated. So essentially, this separates the operations from the transactions. So we can separately scale the payment engine for the transactions from the operations piece. And regression in operations won't cause a regression in transactions and vice versa. Right. And even the separation at the operations layer, since the importers for different data stores are different. For example, a Cassandra importer can be written, which can heavily borrow from the other importers in terms of what events it needs to parse and store in what format. And the code remains decoupled for the importers. Right. Now, in this one part is the operations web connects to the asset transactional asset database like MySQL or MariaDB. And Kibana, Grafana usually connects to Elasticsearch and Prometheus. So we're going to dive into some use cases and see how Payment Hub orchestration helps and where does it not link with the claims, right? So what we feel is having this orchestration engine also ensures things like faster transaction turnaround time, lower transaction error rates, and that is faster distinction between recoverable and non-recoverable errors, and codifying it, right? So a citizen developer, like citizen developers being those who use low-code platforms, can create a design document like this in Bpm, in standard Bpm notation. Right. So this is an example where we have adopted the GSMA mobile money international remittance specifications to make multiple Payment Hub instances interoperable with each other. So if you're operating in different countries and it's not transactions in one country cannot be processed in data centers of another country, right? Since international remittance also has KYC information, right? Or it could have for cash out, it could have biometrics related information. So this workflow illustrates how one payment hub can talk with another payment hub, right? So the payment schema connectors can again talk with the channel connectors of another payment hub. Right. So payment hub itself is a payment schema, which there can be an internal looping. So this is the use case which does that. So all of these red blocks are essentially talking with another instance of payment hub. Right. So to separate the color coding, the red ones are the payment schema connectors. The purple ones are the ones which talks with the store of value, right? And the blue ones are notifications to the channel from which the API calls came, or to the operator. One of the key things which is not losing where a transaction is, right? So the components are all stateless. This workflow, the diagram is stateful, But when writing code, developers can often make mistake on the transaction boundaries, on where on managing the state, right? Now, this also gives more visibility on where the boundaries are, right? Where should the funds be blocked? And in case the transaction fails, when should the funds be released for reuse? Maybe even for retrying the same transaction, right? So this doesn't encounter cases where the funds are blocked and without additional funds, you cannot retry a transaction which is stuck. So we're going to come to a collection use case. This is built on the M-Pesa collection use cases. So this is particularly the request goes to the customer. So it's a B2C business initiated request to pay. The business is requesting the customer to pay. And again, it validates whether the channel connector sends information about the transaction, and it's standard. So there are no different parts for the AMS, different parts for the payment schema. So channel connector exposes a set of standardized schemas. One which is developer friendly with minimal fields, and others which are open banking standard specific, right? Like GSMA mobile money standard specific, or it could be open banking UK standard specific. Depending on which API consumption pattern you want to promote, you can promote a particular set of APIs. So in this one, reusing the identifiers, it validates in the AMS whether it's the right account. If the transaction goes through, right, will it be routed to the right place? Can it be routed to the right loan account can be settled? Because a lot of the complexity in payments comes from refund. And if refunds can be minimized by making sure that uh, transactions, when a transaction is successful, the money can reach the final destination in the rails appropriately, then refunds are also minimized. This is a assisted mode. In India, we primarily work all the payment schema connectors on top of the open banking layer. We make different assisted mode transaction. So every typical transaction, we have a variation where it's in assisted mode. So this is a domestic money transfer, or in terms of open banking terminology, peer-to-peer transfer, but in assisted mode. So this adds beneficiary management also to Payment Hub, where the beneficiaries could be managed here we are managing the beneficiaries with um, our AMS. It could also be managed, the beneficiaries can also be routed to G2P, OpenG2P, or any other beneficiary management system. Right? And the OTP retry mechanisms, the timeouts, the retry counts, everything is baked into the workflow. Right. So here in this use case, the customer approaches an agent, withdraws some cash using biometrics into the agent wallet, and the agent does this transaction on behalf of the customer. So we have been, over the last year, we have been exploring some bulk processor use cases for G2P and B2B for bulk payouts to government to person, that is beneficiaries, or beneficiaries in the business context, which is like partners and vendors. So the channel connector stages the large file which comes in and pre-processes it in terms of separating it by different payment schemas or topics and pushing to each um, separate topic. Before that, it organizes the data based on which fields are there, for example, which like how should it be ordered, right? And if penny drop is possible, it will first initiate penny drops before attempting the right transaction, before attempting the set of transactions. And based on every payment schema will then rearrange the subset of the file and collate all the data and merge it back with the original transaction uh, file to have a consolidated view of which file, what has been processed and what hasn't been processed, and where are the transactions by error codes. Right. So you have the convenience of a CSV file which you can straight inject into the bulk processor and format the data as per requirement, like mention the interoperable identifiers based on the payment schema connector. If it's a bank, you can provide direct bank transfer details. If there's an open banking, you can provide the interoperable identifiers for the open banking layer. Right? If it's mobile money, you can provide the mobile money. So the interoperable identifiers can also help in this categorizing by the different payment schemas. Right. So again, since this can be a huge load, right? So Zbay helps in back pressure. So when there are resource limitations, it introduces back pressure so that it can be processed as fast as possible without entire degradation of the system health. Right? In payment schema connectors, if you can see that third party payment systems often fail during load, and after failure they don't come back immediately. They have a degraded service quality for couple of hours or for a couple of days once they experience a huge peak load. Right now, it cannot scale fast and scale back down fast enough. So Zbay helps in that. It has been load tested and found to be able to do up to 5,000 workflows per second. Right. So in payment rails, cascading denial of service is prevented. Right. And in the bulk processor, again, it adds the visual element to creating, orchestrating workflows, having multiple payment schema connectors, providing redundancy. And this, so the low latency is also ensured by gRPC. It doesn't use REST. It uses protobuf. So not only the embedded database, but the way each service communicates with the connectors is also like low latency. Right. The Moja loop workflow, which can be explored in a broad scope in terms of having different AMSs connected to it. The POC was done with Fynarfin, right? And here Moja loop is a switch, a country level switch, right? So those blocks are in orange. It works like international remittance. There is a quote, and that quote only after confirmation of the acceptance of the quote does the transaction go through. There are some interesting nuances here in terms of, right, if AMS fails to book the funds, the transaction is successful. Then there's a automated flow. So if you can see the gear icons, these are service tasks which will do it in an automated way. Or it could also notify the operator to handle the edge case of transaction is successful, but the funds haven't been booked in the AMS. So the operator can do a manual override to see what the situation is on the AMS side and take an appropriate action where the workflow can't. So this introduces a nature of hybrid, like handling all the edge cases, right? Like even if the 1.51%, 2% transactions are failing, but they're failing due to 100 different reasons, right? This could like quickly classify the transactions into recoverable errors that should just be retried, or non-recoverable errors, which either if it happens before a certain part in the workflow, it can just fail the transaction so that it can be retried, or it could bring in a manual intervention to see, okay, what is the state of the transaction at the third party, even though it's saying pending, or why is the AMS like analyzing the AMS error code if the AMS error dictionary is not sufficient. Now we're going to go through some of the deployment models that is available in the documentation, right? Like so, one easy way of segregating the deployment models is whether it's bare bone or whether it has to be fully scaled, whether if it's mission critical or how much redundancy is required. On that, there are three templates, right? We have introduced a couple of more templates depending on how many services need to be included. A superset template, which includes all the services involved, and other templates, which like G2P template, which only uses a partial set of the services. So these building blocks can again be packaged in different ways for different organization profiles. This shows interoperability of the instances with Mojaloop being the national switch to which the other payment orchestrators are linked to, and the AMS is being linked to these payment orchestrators, and providing that financial inclusion at the country level. Is another example of how on top of the channel connector, we have open banking adapters to transform the APIs from one format to another format, especially if the fields related to it are all present in both the formats, just that they need to be transformed into different names or different JSON structures. And yeah, and this also talks about particular like API gateway, which the diagram is talking about WSO2, but we have been using Gravity and Kong. And I'll pause for some questions before going for the next slide.
Yeah, and I'm not sure if it's going to come up in the demo, but I know a lot of what you've worked on was the Helm charts and making the payment hub more deployable. Can you speak to some of like the toolkit that's now in place for more easily deploying the payment hub in a cloud or on-premise environment?
Yeah. So other than these three Helm charts, we as I was saying, there's a superset Helm chart which packages all the components together. So superset Helm chart is an extension of the barebone Helm chart, but with all the services involved. And we have one Helm chart which is specific for multiple AMSs connecting to the same payment schema. So that is more specific for organizations where the AMS is not wallet, but an AMS is the accounts are loan accounts and not wallet accounts. So that template is meant to include only the collection related payment schemas, not the outbound payment schemas. So collection payment schema is one of the Helm charts. The G2P for bulk processor and the bulk disbursement payment schema connectors is one hand chart for G2P. Then there's one international remittance hand chart, which is for payment hub interoperating in different countries and providing an abstraction layer to different banking as a service providers in the backend. So that hand chart is more focused towards leveraging the core. Yeah. So all of those are extensions of the barebone hand chart. There's the packaging of the components, the payment schema connectors and the AMS connectors, and the other services are slightly different. Just, yeah. So the generic use cases, the request to pay, bulk payment, agent initiated transactions are the ones we have primarily focused on and implemented. The bottom half is where it's slightly underdeveloped in terms of capacity right now. So things like merchant initiated transactions and ATM initiated cash outs and more refund flows. Yeah.
Okay, thanks, Avik. And I fielded just one question that came through the Q&A. So I answered Jitendra's question. So I think you can continue on. And do I need to add in any other panelists to share their screen, or will you be sharing screen for the demonstration question?
Yeah. Yeah. So Jitendra has asked for interbank transfer. As I understand that Mojaloop is doing the interbank transfer. Is this mandatory that both the banks should have payment hub on their sites?
Oh, yeah, I answered his question in the chat too there, Avik. I think everybody should see that.
Okay, right. Yeah, I don't see any other open questions. So, yeah, I'll just finish this then. So we have partially developed voucher so that the vouchers can be distributed through payment hub and can interoperate with the existing payment hub models around proof of delivery. So bulk processor also comes with the acknowledgement or proof of delivery, which the voucher service can benefit from. The fees is often a part which we find a limitation in, like different type of fees are not always supported by all the banking as a service providers. So providing a fee segregation in payment hub itself, and then applying the limits for different KYC categories, and yeah, QR codes for G2P and trust mechanisms to identify all the parties different parties which interoperates with payment hub, like third-party payment initiation service providers. The tenant or the DFSP is the tenant, and the switch or the payment schema connectors. Right? And exposing PIS PAPs for different open banking standards for account aggregation purposes. And international remittance also, it fits well with this use case. Biometric based payments and yeah, interoperability with distributed ledgers and AML is also there. Some of these design considerations we will cover in more details in the next part of the demo. So I'm just going to briefly go over it. So a transaction, because of any service disruption, doesn't go for a toss. It still, the state is managed by Zbase, so pod restarting the payment flow still survives and can recover from where it started. The timers can survive failures. The incoming messages are can be correlated across different nodes in the cluster. And these are some of the payment errors which are thrown right now. Yeah. So I would hand over the session to Danish. If you have any questions before that, feel free to ask.
I would like to show some of the visualizations we have created. So the main purpose of these visualizations are basically for the reconciliations and like basically monitoring the transactions, seeing the state of the transactions, either it is successful or not, and all the different things. So, so on a higher level, we basically have three major dashboard. First one is aggregations. So aggregations basically shows all the like the additive or the exhaustive count of all the different types of transactions. That is how many transactions are failed uh, and how many transactions are failed in specific scenarios. Like in transactions decision gateways, we can see there are multiple counts where like zero transactions have been failed with the party lookup. So party lookup is basically like the verification of the account to whoever is receiving the money. So yeah, this is specific to the collections like payment thing. So this is the aggregation dashboard. Next one is debugging. This is more of use for debugging purposes. Here we can see all the different instances ID for the specific BPMNs for each of the instance and what all steps is basically taken. Like here in task state, we can see all the different steps. So these are all the different blocks which just I showed like different colorful blocks inside the BPMN. So we can see that which path it took by basically debugging it from this task state. And here we have the process variable. So process variable basically is like, for example, we started a transaction. So all the different fields and variables related to that specific transaction. So here we can see like we have the account ID. Here we have like buy goods request body, what was the payload, and all those things. Yep. And then the third one is the granular. So granular is more for the reconciliation purposes. So it's basically for all the like failures, like if you want to monitor or check what might be the possible reason of failure. So it basically has all the different logs and error information. Like for example, we can see here one transaction which is basically failed, and this is the error information, entire payload for that error. Yep. So that's it. So these dashboards are basically used for like monitoring and debugging purposes. Now moving on, I would like to give a quick collection demo. Yes, would you like to add something?
Yeah, can we just go back to the dashboards? I would like to highlight a couple of points.
Yeah.
Yeah, let's go to the granular one. Yeah. So in the documentation, you might see that we were using a service called ZB Operate, which was a proprietary service. So these dashboards essentially replaces ZB Operate with similar visualizations here. to track the state of the transaction and take action on them. So the different types of errors I would again like to classify here. One is incidents. Incidents is where it's internal errors, right? For example, server-side internal errors, not due to any third parties, not directly due to any third parties. Then the transaction errors, again, these are the ones which are parsed into specific error codes, error status, and descriptions, which were shown in the aggregated dashboard. And so these error descriptions are classified into two formats: recoverable error codes, which the workflow itself recovers from, like keeps retrying, like network error. It will keep on retrying till it gets a different final state instead of considering it as a non-recoverable error. And so these two sides help in clarifying like how many of them are non-recoverable versus recoverable, and how many of them are internal errors in the code which comes in the incidents part. Right? And if you can scroll to the bottom part. Yeah. Yeah. So transaction, keep on going down. So the different errors from the third party are again classified into, yeah, can you go back up slightly? Yeah, into different timeouts. So there are, this is where we are trying to optimize the turnaround time. And for collections, especially when our assisted mode and collections, the turnaround time is critical, where customer is waiting for the response to be able to proceed. So whether it's a refund or the final state of a transaction, it's really critical that it's done as fast as possible. So these timeouts also provides visibility into the different reasons for timeout, and where was this environment doesn't have all the data, but it shows like where did it spend most of the time uh, before the timeout happened, right? So it gives us also enough insights to request a third party that, yeah, this part shortcode push, this is where it's like not able to handle the load. And usually we have 2x percentage transaction failure rate, but because of these timeout traces, we have found that the error rate today is like much higher on 10%, 15%. So giving, it's not only mentioning the information, but also giving some insights into where it timed out. Yeah, please go ahead, Danish.
Yeah. Thanks for adding those points. Yeah. So moving ahead, like since we are talking about monitoring and debugging, we have another set of service called ZBay operations. So ZBay operations basically contains some of the endpoints, which is useful for like getting different types of like state in the ZBay. Like for example, if we want to get all the processes which are having basically some state, like say it is not completed or something like that, or we want to like say for example cancel a workflow forcefully in between, so we can pass the workflow ID and it will cancel a workflow. So this endpoint is for that. So yeah, so there are multiple endpoints which we can use for monitoring purposes. We have like get all the variables which are currently set for a particular instance of a workflow. Another important endpoint is uploading a Bpmn. So in like orchestrating the services, we basically the first step is to add the Bpmn in the ZBay engine. So for that, we basically need to use the ZBCTL, which is a ZBase client for like carrying out the different tasks for the ZBase engine. So for if say example service ZBase service is deployed in Kubernetes, so we might not have the access to the cluster directly in some scenarios. So we can use this ZBase operations API endpoint, which will basically upload the Bpmn. So for example, let me fire this up. Like this is one of the test Bpmn. And let me check if host is set properly or not. Yeah, so since it created successfully in the 200, so now this Bpmn is uploaded. So we can basically use this for uploading multiple Bpmns or like creating the multiple versions of the same Bpmn. So we suppose we want to update this, we can simply update the current Bpmn and then we can upload it. So it will basically upload it in the ZBase with the updated version. So yeah, this was about the ZBase operation service. Now I would like to show a quick demo of firing a transaction or collection request. So for collection request, as Avik told, we in channel connector, we have a like generic set of payload, which is basically developer friendly with minimalistic and less fields. So it basically has a pair where MSI is the user's phone number and account ID. And then for amount, we have the currency and the actual amount. So this transaction type, this map is basically used for deciding which type of transaction it is or which specific scenario it is related to. So yeah, this is like like one of the important field. So for example, if we are using different AMS, we can have a sub scenario there, which will be like deciding which path to take and basically which flow to initiate. So yeah, let me just check this. Yeah. So yeah, this transaction is being initiated and we have a transaction ID. So now inside operations app, we have a endpoint which will basically return the state of the transaction. So we can fire it and we can see 708. Yeah, so this is the current state. Basically, it is saying as state has failed. We can also confirm this, like why this state is failed. It might be because of some like business shortcode or like organizational specific credential issue. So since it is testing environment, it is not working. So like this transaction has been initiated and it has been completed. So this operations app endpoint like get transaction request basically picks data from the MySQL, which Avik told is like a database where we basically have all the different sets of like transactional data for monitoring the state of the transaction. So all the like data published to the Kafka, like the state of the entire transaction, that is basically consumed by the imported RDBMS and it parses and dumps it into the database. And yeah, and it basically also updates it based on the all these eBay events published to the Kafka. So yeah, so this is like currently failed, and this endpoint supports all the different kinds of queries. Like for example, we can have here start from like this particular date, or for example, if we want to have all the transaction that are in progress. So like we can see like there are no transaction which are right now in progress. So like the transaction which I just showed was failed. So yeah, now you can see we have a failed transaction here. We have another failed transaction here. So yeah, this endpoint is used for that. Apart from that, operations app also has a separate module which is basically responsible for handling the error codes. So there are different error codes. Some of them are recoverable, some of them are non-recoverable. So throughout our payment hub, we basically, wherever we have error code kind of thing, we basically query our own database, which will be basically a single point of truth for telling that, okay, this is recoverable error code or this is not a non-recoverable error code. So let me try fetching it. Let me see if it has some. So yeah, this is the M-Pesa specific codes. So these are the error codes which are basically recoverable. So inside collection request for entire Bpmn, whenever we encounter any error, we basically checks for the transaction errors from this database if it is recoverable or not. And if we find that it is recoverable, we basically retry it based on the retry count and the exponential fallback logic. So yep, that was a quick demo of channel connected transaction request. Next, I want to just show a quick demo of some of the Bpmn, not a demo, like quick walkthrough of the Bpmns. Before that, if we could take up some of the questions, if anybody has any.
Yeah, I didn't see any questions at the moment, Dinesh.
Okay, yeah, so I'll continue.
And then Avik, just while Dinesh is switching over to show the Bpmns, did you want to speak at a high level just around like the sort of use case for the M-Pesa flows that you have been orchestrating through the payment hub? So you don't need to refer in detail to the customer, but at a high level, like the flows and the volumes that they are sending through the payment hub at the moment, I think would be valuable to speak to.
Yeah, we are handling around 2 million transactions a month for collections, M-Pesa collections. And yeah, for outbound, we are handling far lower loads, but for bulk also we have tested it with 2 million records.
Okay. And for those inbound collections, like what is the flow at a high level for those, Avik? So
yeah, so primarily from a USSD channel. So the channel there is USSD. So the USSD based orchestrator basically based on what the menu options in the USSD, it selects account ID, the primary KYC or secondary identified and secondary identified. Like MSISDN is one identified, which is interoperable with the AMS and third-party payment schema connectors. So MSISDN is usually the primary, and the secondary identifier is something like a foundational ID or a loan account ID. So based on these two IDs, it decides which AMS it has to be routed to and confirms whether the account exists. And there's a due amount for that. Like there's an outstanding amount or invoice or whatever. That amount, the due amount and the paid amount is the same, so that there need not be additional cases around refund, underpayment or overpayment. And after that confirmation or like party lookup confirmation, it initiates the transaction, asynchronous transaction request with M-Pesa, where it's a short code gets pushed to the M-Pesa wallet of the customer, and I guess SMS and a notification is sent from M-Pesa side, to which there's a like 90-second timer within which the customer has to accept or reject the collection request, or else it times out. And yeah, so there's one part which waits for the callback and checks whether the callback is coming from the right source. The other part, if the callback never comes, gets dropped by the network, it will query the transaction state. And post which it will book the amount in the AMS, or if the transaction fails, then it will send a failure notification. And yeah, if the settlement is successful, then a settlement notification gets sent. The notification service is an abstraction layer which doesn't have a lot of functionality inside it. It's again for orchestrating between ZBay and other more specific type of notifications. So in our case, mostly the notification service has been communicating with a message gateway for three purposes. One is for sending failure. One is for sending success. So message gateway is the one which provides all the options, whether it's Twilio or Telerivet or Jasmine. That supports around 4 to 5 SMS providers. And it message gateway and notification service also supports a proof of delivery. So the message can be delivered in collection mode again, where the workflow will not end till the proof of delivery comes back from the customer via USSD or SMS saying that yes, they have successfully received the delivery. And that proof of delivery gets collated back to the bulk file.
Okay, thanks for speaking to that, Avik. Sorry, Dinesh, I'll let you go through the Bpmn diagrams now.
Yeah, so this is the M-Pesa collection Bpmn. So I would just like to highlight some of the important things and implementation we came up with here. So the first thing which Avik also talked briefly about is this, the waiting for callback and the exponential fallback logic here. So there were multiple scenarios like where there were like multiple reasons where the M-Pesa or the Safaricom was not basically sending the callback. So it might be possible, like in some scenario, they are delaying the callback, or in some cases it might be possible they are not, or they are not also not sending the callback. So for all these cases, we basically have this logic to handle that scenario. So waiting for callback is basically a task where we basically wait for some time, and it is an exponential timer. So like first we wait for some, let's say 2 seconds. Then after that, if we don't get like callback from Safaricom, then we manually check the transaction status. So in the get transaction status, we basically have that logic of error codes where we get the result code and try to make a decision based on our own database of error codes, recoverable error codes, and based on the response Safaricom returned. And then eventually making a decision of either a transaction is successful or not. If it is not, then we basically wait for the callback again to see if the callback is returned. But in some scenarios, get transaction status also has some of the result code which basically maps to a complete failure. Let's say, for example, the insufficient balance. So Safaricom didn't send any callback, and in the transaction status, we get a error code corresponding to a sufficient balance. So in that case, we basically skip the callback, waiting for callback logic, and we eventually face the transaction. But for the else case, we basically wait for first time we basically waited for 2 seconds, then this time basically 2 to the power 2, then in so fourth manage. Yep, same logic we have for the notification also, for the waiting for callback logic. Another thing we have here is like basically this entire BPMN has two parts. One is the transfer or the collection parts, and another one is the notification part. So we can, like on a high level, disable this entire notification part. So for example, if we don't want user to get a separate notification from our payment hub side, so in that case, we can disable the entire notification part, and the notification, entire notification worker and all this logic won't be executed. Yep, that's it. Another thing, another BPMN I want to show is this outbound transaction BPMN. So this is basically for the DMT, carrying out the domestic money transfer kind of transactions. So in this BPMN, we have basically multiple interference from the agent. So it is like required, the agent is required to enter the OTP, the sender information, and beneficiary details. So that's why it has much more intermediary steps. So for all those things, we have different APIs in the channel connector, like for submitting the OTP, for submitting the sender information. And then we have an entire separate beneficiary module, which is basically the API for submitting the beneficiary details and all those things. Yep. Yeah. That's it. Avik, would you like to add anything?
Yeah. So the geared icons are the automated tasks, and the message icons are the ones which is waiting for a user input.
Yeah. So these are all the service tasks, which basically corresponds to the function in sitting in some of our microservice. And this is basically waiting for some external call to Zbay, which will basically tell Zbay, okay, you are basically sending a request to Zbay with some variables or some inputs. Yeah, that's it from my side.
So there are also libraries, common SDK kind of a common library where the utility functions are packaged, so you can use that for digitally signing the payloads before sending. And yeah, so it will encrypt the data with the private key.
Oh, and then Avik, I think there's one question from Lokesh around, is ZB managing all these workflows?
Yes, right. So to add a bit more information on Zbay, each box presented in the diagram is a Zbay worker. So that Zbay worker is polling the Zbay engine to understand how many tasks it need to accomplish. For example, if the task is to fire a transaction request, right? It will, rather than Zbay telling each worker that calling out to each worker that these are the tasks you have, right? The workers will poll Zbay engine for the outstanding tasks, and then create that many worker instances. So again, Zbay is stateful, but the code writing, the Zbay workers is stateless. So less mistakes can be made there.
And then Avik, were there, I know we didn't get a chance to, but in the operations interface, like have there been any changes made this past year to the web app that provides operations interface? I wasn't sure if we added any additional screens into that.
Yeah, we have upgraded, the screens are more or less the same. We have upgraded it to Angular 13, and previously it was made for the outbound transactions, and now it also includes inbound transaction use cases, the C2C,
Oh, good.
B2C, and B2B.
Oh, good. Okay. Yeah. And so I think as one item of it would be good, because I think we were going to share it, but it would be good to share just a list of all the enhancements that have made and pointing to, where those upstream changes are made. Because I think it would be good to be able to show, what sort of is the delta between the current Payment Hub upstream repositories and what was there like a year ago. As I know, a lot has been improved and changed. And I think there's one or two more questions, or one other question we'll try to get to as we wrap up. So I think there's one question in the chat, Avik. I, for some reason, can't open it myself. Yeah, so Sagaye from Ethiopia, he was asking, is there a 3DS rule for card-based transactions? As a payment hub includes card-based, do you want to speak to that, Avik?
Yeah, no, so yeah, the short answer is no, right? Yeah, the long answer is with Visa and MasterCard supporting more tokens. I mean, right. So with tokenization and with with the advent of HSM as a service, right? It makes it makes it easier to develop that in case you're looking to develop that.
Okay, well, we're at 2 minutes over the time we had allotted. So I want to thank everybody for attending, and thank Avik and Dinesh for their slides and demonstration. So as next steps, we'll send out the recording. We'll try to begin documenting, as Avik had at a high level, more of a roadmap of what we anticipate, might potentially be forthcoming in the Payment Hub. And we look forward to interacting with you and understanding more of your use cases that you'd like to explore with the Payment Hub, and hopefully getting the opportunity to try to work with you to make those enhancements and help you with those deployments. And we will try to get that lab environment up and running once again. But if you do see a need for Payment Hub as part of your operations, or have questions about how it could be utilized or what use cases it could support, don't hesitate to reach out to myself or Avik, as Avik and the team at Fynarfin are eager to help others with their deployments and work with you to build out the solutions you'd like to enable on top of it. So thank you everyone once again, and we'll try to keep you abreast of the ongoing progress of the Payment Hub on a more frequent basis than we've done so. So thank you everyone. Take care and have a good rest of your evening, morning, or day.
Thank you, everyone. Have a nice day.
Thanks, everyone.